Matrix multiplication with np.dot is one of the most fundamental operations in linear algebra and data science. In this tutorial, you'll learn how to perform matrix multiplication using NumPy's dot function. This operation is essential for machine learning, data transformations, and scientific computing. Let's dive into understanding how matrix multiplication works and how to implement it efficiently in Python. Matrix multiplication is a fundamental linear algebra operation that combines two matrices to produce a new matrix. The key rule to remember is that the inner dimensions must match. When you multiply a matrix of size m by n with a matrix of size n by p, the result will be a matrix of size m by p. Notice how the inner dimension n must be the same in both matrices for the multiplication to be valid. This operation is not just simple element-wise multiplication, but a more complex calculation that we'll explore in detail. Let's see matrix multiplication in action with a concrete example. When we multiply a 2 by 2 matrix A containing values 1, 2, 3, 4 with another 2 by 2 matrix B containing values 5, 6, 7, 8, we get a result matrix with values 19, 22, 43, and 50. Each element in the result is calculated by taking the dot product of the corresponding row from matrix A and column from matrix B, for instance. The first element 19 comes from multiplying 1 times 5 plus 2 times 7. The basic syntax for matrix multiplication in NumPy is straightforward. First, you import NumPy as np, then you create your matrices using np.array. For example, matrix A is created with values 1, 2, 3, 4 arranged in a 2 by 2 structure, and matrix B is created with values 5, 6, 7, 8. To perform the multiplication, you simply call np.dot passing matrix A and matrix B as arguments. The result will be stored in the result variable, giving you the multiplied matrix. There are several critical rules to keep in mind when using np.dot. First, the inner dimensions must match. You can only multiply a matrix of shape m by n with a matrix of shape n by p second. The resulting matrix will have the shape m by p third. Order matters in matrix multiplication. A times b does not equal b times a, unlike regular number multiplication. Finally, if the dimensions don't align properly, NumPy will raise a value error to alert you of the incompatibility. Matrix multiplication works with various dimensional combinations as long as the inner dimensions match. For example, you can multiply a 2 by 3 matrix with a 3 by 2 matrix, resulting in a 2 by 2 matrix. Matrix A with dimensions 2 by 3 contains values 1 through 6, and matrix B with dimensions 3 by 2 contains values 7 through 12. Another example is multiplying a 3 by 1 matrix C with a 1 by 3 matrix D, which produces a 3 by 3 result matrix. These examples show the flexibility of matrix multiplication across different shapes. NumPy provides 3 different ways to perform matrix multiplication, and they all produce identical results. The first option is using the @ operator. Written as A at B, the second option is using the dot method directly on the matrix. Written as a dot B, the third option is the function we've been using, np.dot with A and B as parameters. You can choose whichever syntax feels most natural to you, as they're completely interchangeable and equally efficient. Matrix multiplication with np.dot has numerous practical applications across different fields. In machine learning, it's essential for neural network computations where layers of neurons are represented as matrices. For data transformation, it enables coordinate rotations and scaling operations. In solving linear systems, matrix multiplication helps model and solve complex equations. Finally, in computer graphics, it powers 3-dimensional transformations and projections that create the visual effects you see in games and animations. Mastering this operation opens doors to advanced computational techniques.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.